Hello everyone, welcome to Chemspires. Here we will look into problem 1.8. Determine the molecular formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen of mass. So first of all, step 1 is to calculate the relative number of moles of iron and oxygen using this formula. That's nothing but relative number of moles of iron will be equal to percentage of iron by mass by atomic mass. The same way we will calculate for oxygen. It is percentage of oxygen by mass by atomic mass. So let's start. In the question, percentage of mass of iron is given as 69.9% and percentage oxygen is given as 30.1%. So 69.9 by atomic mass of iron is 55.9. Remember this. So on dividing we will get 1.25, and let's calculate for oxygen. Percentage of oxygen is given as 30.1 by atomic mass of oxygen. This is dioxygen, so the mass will be 16. So it will be equal to 1.88. So we have got the relative number of moles. Let's take the ratio. So ratio of number of moles of iron is to number of moles of oxygen is equal to 1.25 is to 1.88. So since this is in decimal, let's try to convert them into whole number. So let's divide by 1.25 on both sides. We'll get as 1.25 divided by 1.25 is to 1.88 divided by 1.25. So it will be equal to, this both gets cancelled, 1 is to 1.88 by 1.25 is 1.5, and again it turns out to be decimal. Therefore let's try to convert into whole number. So let's multiply by 2 so that 1.5 turns out to be 3, and 1 into 2 will be 2 is to 1.25 into 2 will be 3. So we'll get the answer as 2 is to 3. So now we have got the whole number ratio. So this is the empirical formula of this iron oxide. Iron oxide general is FeO. So let's write 2 as the subscript of iron and 3 as the subscript of oxygen. So this is the empirical formula of this particular iron oxide. Now let's calculate the molecular formula. So empirical formula we have found out as Fe2O3. To find the molecular formula, let's multiply this by a whole number n, and to find the whole number we should divide the molar mass of Fe2O3 by the empirical formula mass. So molar mass of Fe2O3 is, for Fe atomic mass is 55.9, so 55.9 into 2 plus 3 into 16, which is equal to 159.8. The same is for the empirical formula because it is also Fe2O3. So now let's substitute this in the n. So it will be 159.8 by 159.8, which turns out to be 1. So n value is 1. So let's substitute the value of 1 there. So we'll get the molecular formula as Fe2O3.